Hello, good evening students. Today we have to discuss about AC series circuit. Before going to AC circuit analysis, we have to know RLC. In once again, in pure resistance AC circuit, phase angle is 0 and both voltage and currents are in phase and power equal to V into I watts. In number 2, in pure inductance AC circuit, phase angle is 90 degree, that is current lags the applied voltage by 90 degree and power equal to 0. Number 3, in pure AC circuit, in pure capacitance AC circuit, again phase angle is 0, current leads the applied voltage by 90 degree, again power expression is 0. These three things you have to remember. And similar fashion, impedance in pure resistance, it is R. Impedance in pure inductance, it is inductive reactance, XL. Impedance in pure capacitance, it becomes capacitive reactance. One side always you have to remember and recall daily for better confidence level. Now you consider R be the resistance and L be the inductance. These two are connected in series. This series combination is connected to a voltage source V equal to Pm sin omega t. Hence, let I be the current. Let I be the current flowing through this series combination. Same current flows through the resistance and same current flows through the inductance, because in series combination same current flows, but the voltages are different. Across the resistance it is VR, across the inductance it is VL. So in DC circuit the total voltage equal to algebraic sum of these two, but in analysis of AC circuit the total voltage is vector quantities, vector sum of these two voltage drops, that is vector sum of voltage drop across resistance VR and voltage drop across inductance VL. Try to understand. So another two important diagrams we have to consider. One is known as voltage triangle, one is known as impedance triangle. If this derivation may be asked in examination, these are all necessary. You have to draw electric circuit diagram, number 1. You have to draw voltage triangle, you have to draw impedance triangle to get the good marks. So you consider OAB is a voltage triangle. OA represents voltage drop across resistance, and it is continued because OA is voltage vector and I is also in the same line. I current is also in the same line because V and R are in phase. V and I across the resistance circuit are in phase. OA is the voltage drop and continuation is I part. So both are in phase. And in voltage triangle, vector OA represents voltage drop across resistance. This is given by I into R. And AB vector represents voltage drop across inductance. Voltage drop across inductance I into XL. So OB represents voltage drop. It is applied voltage. OB is represents, it is applied voltage. So from the voltage triangle it is observed that OB, it is applied voltage, is equal to vector sum of drops concerned, voltage drop across resistance VR and voltage drop across inductance L, that is VL. VL equal to I into XL. So before going to that, we have to consider, let V be the RMS value of applied voltage and I be the RMS value of resultant current flowing through the circuit as shown in figure. Similarly, AB represents voltage drop across inductance. It is also called inductive drop. VL equal to I into XL. And OB represents applied voltage V. So from the voltage triangle, it is also clear that applied voltage V is the vector sum of VR and VL. So from the voltage triangle OB equal to under square root of OA square plus AB square. So what you meant by OA? OA is VR, voltage drop across resistance. What is AB? It is VL, voltage drop across inductance L. Hence, replace in terms of current values. VR equal to I into R. VL, voltage drop across inductance, VL equal to I into XL. So next step, you take the I as the common factor. Under square root of R square plus XL square. In next step, you take the current voltage side, this side, that is the ratio of V by I. What do you mean by V by I? V by I in AC circuit is known as impedance, where Z is the impedance of given AC circuit. Impedance equal to under square root of R square plus XL square. Sir, it is very, very important. You work out and remember. So once again, Z is the impedance of RL series circuit. This impedance equal to under square root of R square plus XL square, where XL is inductive reactance. From impedance triangle, it is also observed that Z is the impedance. It is the vector sum of resistance and inductive reactance. As similarly, impedance triangle is drawn with reference to the voltage triangle. So resistive drop, main component is resistance. Again, it should be drawn in x-axis. Inductive reactance, it is 90 degree leading. So it is drawn in positive y-axis. Hence, vector sum of these two will give impedance. Vector sum of these two provides impedance of the circuit. And let theta be the phase angle. Let theta be the phase angle, tan theta from the impedance triangle, inductive reactance divided by resistance. So inductive reactance is XL, resistance is R. Therefore, phase angle equal to tan inverse of XL by R. From the voltage triangle, it is also observed that current lags the applied voltage by an angle theta. So it is the combination of resistance, it is the combination of inductive circuit. Hence, the phase angle is not equal to 0, the phase angle not equal to 90 degree. Which effect is more? Then theta goes towards that. If resistance value is more, then it is nearer to 0. If inductance value is more, then it is nearer to 90 degree. In between, it varies. That means this series circuit has the effect of resistance as well as inductance. This is only meaning. Theta is not equal to 0, theta is not equal to 90 degree. It lies between above 0 less than 90 degree. But main effect is lag. Main effect is lagging, but lagging angle is above 0 less than 90 degree. So similarly, I want to write the expression for instantaneous values. So if the applied voltage is V equal to Vm sin omega t, assume the expression 1. Then which results the flow of instantaneous current. This current becomes I equal to Im sin omega t minus theta. Hence, this current lags the applied voltage by an angle theta. Theta is above 0, less than 90 degree. Next part, if they ask the derivation, you stop up to here, and also question continues. Draw the voltage and current waveforms, means you see the right side circuit, that is voltage and current waveforms. You take the voltage as reference. It's starting from 0, phi to pi. It is red colored. Waveform is voltage. As compared to voltage, minus sign means lag. Current lags the applied voltage by an angle theta. But theta is not 0 and less than 90 degree. Take the careful, you draw less than 90 degree, 30 degree, 40 degree and so on. So next, calculation of power expression. So for this I have to draw one more diagram, left side. Now you see there V and I vectors are lagging by an angle of theta. As taken as V is reference, I lags by an angle theta. So this current can be resolved into two components. One is parallel to applied voltage, another one is perpendicular to applied voltage. So parallel to applied voltage is drawn as I cos theta, which is parallel to applied voltage. It is also referred as phase component, in phase with applied voltage. I sin phi, which is perpendicular to applied voltage. I sin theta, it is perpendicular to applied voltage. Getting the idea? But in AC circuit, the power is given by product of voltage and current. Product of voltage and current. Which current? This current may be in phase with applied voltage. In phase with applied voltage. Which is the current in phase with applied voltage? I cos theta. Therefore, power equal to Vi cos theta. So we may write power equal to Vi cos theta, where cos theta is known as power factor. Power factor. What is the phi? Phi is known as angle between voltage and current factor. Phase angle. Don't confuse. Cosine of phase angle is known as power factor. V, RMS value of voltage. I, RMS value of current. You remember this expression remains standard while analyzing in AC circuit. Please try to remember, whenever AC circuit comes, power equal to Vi cos pi or cos theta. Cos theta or cos pi is referred as power factor. V and I are RMS value. So power is measured in watts. Watts equal to volt into current into power factor. So it may also written as true power. True power equal to apparent power into power factor. Then what is the apparent power? It is the product of V into I. It is the product of RMS value of voltage and RMS value of current in a given circuit. V into I, it is measured in volt ampere, denoted as VA. VA. So true power equal to apparent power into cos theta or cos pi. What is the power factor? Once again, power factor of the AC circuit is defined as cosine of phase angle. Phase angle, it is the angle between voltage and current. Try to remember, sir. This is the last question in your assignment. Up to here you have to prepare, but today I am not having an opportunity to take the class. So you write in assignment. Up to here you prepare this. Again we restart after your first IA test. Thank you to one and all.